Alright guys, today's video is going to be a quick little hit on arrays. So an array is a storage medium, so it's a space that I can stick some information. And in our case, what we're going to do is we're going to start by storing some strings. So I'm going to go ahead and declare an array here, and this is pretty similar to declaring a variable of whatever type it is that you're making. So here I'm just going to make some closing or some square brackets here, so that's telling it that it's an array of strings rather than a single string. And I'm going to call this array herding breeds because I have a thing about herding dogs. I kind of dig them. So the way you declare an array, or a way to declare an array, is to say we're making a string array, herding breeds, and into it I'm going to put some herding breeds. To save some typing time here, I'm just going to copy and paste some herding breed arrays off from the other side into here. So that's our array. Now, the obvious thing you'd probably want to do, the thing we do with most stuff, is like, let's try to print that thing. So we should be able to just do this, right? This ought to work. When I hit run here, I should get out like Aussie, Healer, Border Collie, and instead I get this friggin' thing. That friggin' thing is some shit and a memory address. That's not helpful to me because I don't know what the computer has in its memory there. I was looking for that information. So this doesn't really help you. So if we're looking for information, not just a memory address, the way we can do that is we can, like, I don't know, first let's print out something in the array. So arrays start their storage at 0. So there's a 0 thing in the array, there's a 1 thing in the array, there's a 2 thing in the array. So each thing is associated to a number. That's its index or the place at which we find it in the array. Computer scientists start counting at 0, which is a little bit weird to start with, but I promise will start to make sense pretty fast. So I'm interested in herding breeds, and let's get that first thing out. So the first thing's in slot 0. So let's see if this gets us better output. So we're gonna hit run. We should see here Aussie, great. We see Aussie, cool. If I put a 1 in here, I'll see the thing in the number 1 slot, which is the second slot in the array. And if I put a 2 in, I'll see something in the 3rd slot. So there we go. That's how I could print out some of these. Now, printing them out one at a time is real obnoxious. I really would like to be able to print them all out. So let's print them all out. So if we're going to print out the array contents, the thing we're going to use for that is we're going to use a for loop. And for our initialization, we're going to make an integer I that we're going to start at 0. We don't know, I mean, in this case, I know that there are 3 things in the array. If you're not sure, or it might be subject to, well, it kind of can't be subject to change later, but if you might change it later, probably want to do herding breeds.length here, and then we'll do incrementing by 1 to pop through our array 1 item at a time. And then we're going to take our printing 1 item out code. We're going to drop that in here. And instead of 0, we're going to put an I there. Okay, so this should print out our 3 items. We'll see Aussie twice because it's being printed out by this line as well. Remember, as I'm writing this comment, I'm reminded that I should reiterate that every array starts its storage at position 0. So this is the first slot, which is index 0. Okay, now let's see a common error here quick. So I'm just going to take herding breeds.length out of here, and I'm going to put a 4 in there. Let's say we didn't know exactly how long the array was, and we guessed and got something that was incorrect. Here we're getting an exception. That exception is an index out of bounds error. You're going to see these a lot because getting the right indexing is kind of hard. Not because it's hard in absolute terms, just because you'll have a tendency to write a number in here, and then you'll go back later and you'll add another option to this list, and that'll cause it to break. So just go ahead and use the length attribute for that. It makes life a lot easier. All right, so this is one option. This is stopping. So the last item in the array is at whatever the length is minus 1. We really maybe could do, I don't know, we could do a bit better. Let's format this just a little bit to make a nice sentence here. So let's do the dth item in the array is, and then we'll use an S for string. We'll use a new line, we'll put the period before the new line. How about that? And then we'll close our quote there. All right, so that should print us out some nice looking, what happened there? D is not a string. Oh, so this was supposed to have 2 inputs, right? An integer for which item and a string. I just put in the string piece, so I need that integer I in there as well. Okay, so we should get the 0th item is Aussie, the 1st item is Healer, the 2nd item is Border Collie. You'll notice those are all kind of wrong. We could fix that. It'll take a minute. Let's not fix it now. So the other thing you might have noticed is I spelled healer wrong, so let's fix that. So if we want to fix something in the array, we want to go into the array, get the item that we want, so that's item 1 that's wrong, and I'm just going to overwrite it. So this is me replacing what's in the first slot, right? The second slot, which is index 1. I'm replacing that with healer. Okay, great. So this is not hella readable though. So I'm going to show you a more readable printing. So if we want more readable printing, we can do for a string that I'm going to call breed, which is in the herding breeds. Then we're going to do something. And what we're going to do here is we're going to do system out print line, and we'll just print out that breed. Okay, so here we should get same items. Now we can see that healer's spelled correctly here when it wasn't spelled correctly there. This is called an enhanced for loop, by the way. I told you before that I would show you an enhanced for loop later. Here's an enhanced for loop. These are sometimes called a for each loop. They're really quite convenient in a lot of ways. So this is a nice option. This does kind of assume you don't need that index for anything. If I'm trying to print out something like this that tries to tell me which item in the array I'm on, that having that indexer there is probably a good idea. But here I don't need that indexer because I don't care what element I'm on. Okay, let me give you another example here. So let's say we wanted to store something that wasn't just strings. Like, let's store some integers. So I want to make an integer array. I'm going to call this score. And I'm going to go ahead and grab some integers here that I just happen to have laying around. So, great. If we wanted to print these out, so let's do printing with an enhanced for loop. So if I'm printing with an enhanced for loop here, I'm going to do for, and these are now going to be an integer, and this is going to be an integer I'm going to call score in scores. So this colon you can read as in or of. So it's for an integer score in scores, or for an integer score of scores. In is probably easier for most people to wrap their head around. So for an integer score in scores, what do we want to do? Let's just print them out. So let's do system.out.println, and we'll print out those scores. Great. So hitting run on this, I should see a whole list of scores printed out. Great. All right. Let's demonstrate something you could do a little calculation with. So let's find the minimum. Oops. Okay, so for the minimum, I'm going to need a variable to keep track of what that minimum is so far. So I'm going to call that min. And I'm just going to start it with the item in the 0 slot. And then let's do for an integer score in scores. If the score we're looking at is less than the minimum, so if the one we're looking at is smaller, then we want to say, let's make the minimum equal to the new score. Right, so we'll overwrite what was in the minimum with the next lowest score. So the way that's going to work is I'm going to start by saying the minimum's 73. And then I'm going to say, okay, is 95 smaller than 73? It's not, so I'm going to move on. I'm going to ask, is 87 smaller than 73? It's not, so we're going to move on. Is 51 smaller? It is, so we're going to replace 73 with 51. And then we're going to go, is 76 smaller than 51? No. Is 92 smaller than 51? No. So that'll get us there. And then right here at the end, let's actually go ahead and print that out. And I just happen to have that off over here. So we're going to print out using a formatted string. The minimum value is a integer min. We've got a period and a new line. Great. Should work just fine. We should see the minimum score is 51. Cool. I got a minimum value of 51. Let's double check that's not kind of a fluke. So I'm going to take the score 84 and make it 34. So it has to replace twice in the process. Great, I got 34. It's not a fluke, seems to work. We should probably make the smallest number the one at the end just quick, just to make sure that everything is working. Great, worked. Cool. All right, so what are the caveats to arrays? Like, this is how arrays work. What are the caveats? So the caveats to arrays is they must always be the same size. So this is the biggest, the biggest kind of word of warning about these. Word of caution, word of, I don't know. I'm going to call it caution. So the word of caution is that arrays are a fixed length. If you want to add or subtract things from an array, it's kind of a whole deal. You really are going to have to make a copy of the array and then delete the old one. They're not really made to be dynamic data structures. They're made to be what's called a kind of static data structure. You can put things in and out of them all day long. That's no problem. It's when you want to make the whole thing longer or shorter that's really the problem. So if you want to make something longer or shorter, so if we need to modify length, we should probably use an array list. An array list is a more dynamic data storage structure. So it allows for adding and subtracting things. Some examples. So scores in a class are usually stored in an array. And that's because the number of students in the class isn't going to change. It might go down, but if it goes down, I'm just going to record zeros for that student after they stop attending, right? So keeping track of scores in class is super chilled use of an array because the number of students after like the second or third day doesn't change at all. So we're doing minimal modification to the length of the array, and mostly we're just modifying the things in the array. Something where it's a bad idea are something like bullets in a video game. I need to keep track of bullets for a while, but once they're off the screen, I really want to stop keeping track, and I honestly have no inkling of how many bullets the user is going to shoot, right? I have no inkling of how many Zerglings somebody's going to make in a StarCraft fight. I have no idea how many cows you're going to have in your Minecraft base, right? Those kind of things are best stored in something that's resizable. So if we try to keep them in something like an array, we'll end up having to resize it a lot. That consumes a lot of memory. We're a bit better to go to a different data structure like an array list for that. So I hope that makes sense. There's this, like, if you know how many there are going to be and you're not going to change how many there are going to be, go ahead and use an array. If you're not sure, you might want to look into a better idea. It can be the right answer sometimes to keep those kind of things in an array anyway and just plan on resizing it when you have to. As long as you're not going to resize it very often, it's maybe not the biggest deal in the world. Hope that's helpful. Thank you guys. I will catch you on the next one.